Hey everybody, it's Vasky. We are talking about Chapter 6, Normal Distribution, and these are our notes. All right, so what's our essential outcome today, or our big idea or learning goal? I will be able to identify an observation's percentile and find the mean and median in terms of density curves. So percentile is a big word, and I want to define our measures of center for density curves. All right, let's do this. So, mean. Let's see here. First thing to tackle here, density curve. What is a density curve? Well, you notice here you have a lovely, it looks like a histogram because the bars are connected. A density curve is a smooth curve drawn through the tops of the bars of a histogram. Okay. So, write that down and we will move on. Mean and median, number definition. So what is the number definition of a mean when I'm talking density curves? It is the average. Recall, what is the average? Or how do I find the average? I find the average by adding all my numbers, or add all the data, and divide by how many there are, how many you have. Okay, so average or mean. All right, what is the median? Well, a median is also a measure of center, and the median is, try this again, the middle. So remember, how do we find median? Ordered list, usually from small to big, and find middle, or split it in half. All right. All right. Density curve definition when we have the mean. What is the definition? It's the point at which the curve would balance if it was made of solid material. So if we could put our finger under the curve and have it like a little teeter-totter, where would that thing balance? Okay. What's the density curve definition if we're working with a median? So again, medians go with skewed data or outliers. That is a point with half the area under the curve to the left and half to its right. So remember in the last unit, the last part of Chapter 5b, we talked about medians and modes, and now we're just adding in density, which is basically kind of your area. Little picture to demonstrate this. Okay, if I'm using a mean, I have a pretty normal curve. Okay, and if I was going to try to balance it, okay, it would probably be about right here. If it was skewed, it would move either to the right if I have outliers on the high side, or to the left if I have outliers on the low side. Okay, middle. Okay, let's say we do have something skewed, like this. Okay, I want to find the point where half the area under the curve is to the left and half is to its right. So I have to find somewhere in this curve where I look at the area that's under it and I say, okay, half of it is over on the left-hand side and half is over on the right-hand side. So maybe that would be over here somewhere. I'm just taking a guess. You know, put your finger there. This is where I'm going to balance it. All right, moving on. Okay, some more definitions so we know what we're talking about. Symmetric data. Remember, with symmetric data, both the mean and median will be at the center of the data. Okay, at the hill, like what I showed you with that picture on the last slide. All right, skewed data. The mean is affected by outliers, and we talked about that in the last unit. So it'll be pulled to the most towards the tail, or wherever your outliers live. If you have outliers, it would be pulled towards the outliers. Okay. All right, so let's move on with this. And you can always pause this video in order to write down the definitions. It says label the mean and median in each curve. All right, so I have 3 pictures here. The first picture I would say is what for shape? Well, the tail definitely goes off to the right, so I would say this is skewed right. All right. The middle one we can say is symmetrical, because if I split it in half, it looks like we've got the same thing. It's pretty even on both sides. And the last example here, since it kind of tails off to the left, I would say this is skewed left. Okay, so we have to identify the mean and the median. Well, when you have something that's symmetrical, what can you tell about the mean and the median? Well, I would say they're both pretty much the same. So if I had to choose a letter, I would say A and A. Remember, symmetrical means it's even on both sides, so your mean and median are going to be the same, if not very, very close to each other. Okay, what about a skewed to the right? Which one is going to move because of outliers? Is it going to be the mean or the median? Well, as we learned in the past, when you calculate a mean and add up all the numbers and divide by how many there are, the mean is the one that's going to be affected. So I would say the mean is going to move towards that arrow on the right. So letter C would be my best label for the mean. Where would the median be? Well, the median does move a tad, but just not as much as the mean. So I would say your best choice for median is going to be B. It's going to move slightly, but not huge. Okay, and then obviously skewed left, now our mean is going to be the A here, because it's going to be affected by the skew or the outliers. And our median is going to move a little bit, but not too much. So that's going to be letter B. All right. Percentile. All right. Definition of percentile. This is what we're talking about when we're talking normal curves. The pth, that's fun, percentile of a distribution is the percent of observations equal to or below the value. Equal to or below the value. That sounds to me like an inequality. So equal to or below the value. Okay? This side is going to be less than this side. Okay, so to be in the 99th percentile in height means this. 99% of the sample or the other people who had their heights measured is the same height or shorter than you. That definitely is not Vaskey. I am not the 99th percentile. Never have been, never will be. But maybe it's some of you in class if you're on the taller end of the spectrum. Just a little extra added here. Okay, so this means if you're in the 99th percentile, that means 99% of the sample is the same height or shorter than you. Okay? I'm going to stick. So that means that about 1% are taller than you. And that would be the people in the sample space that got their heights measured as well. All right. So continuing on. So to be in the 50th percentile for GPA, so let's say we're comparing GPAs. It means that 50% of students in your grade have the same or lower GPA than you. Okay, so let's say that we looked at everybody's GPA across the 9th grade class. And if you are in the 50th percentile, that means half have lower grades than you. Lower grades or the same grade as you. And the other missing component would have a better grade than you. Okay, so continuing on. What would being in the 10th percentile for weight mean? If I'm in the 10th percentile, I would love it. Then I could stop my diet. All right, if I am in the 10th percentile, that means what? That means 10% of the population who had their weights measured are going to be the same weight as I am. Or way less than you do. So, you're on the skinny side. All right. So here we have a dot plot that shows height in inches. Obviously, we've got 25 pieces of data because that's what the N means. We've got a mean of 67, standard deviation. Remember, mean is x bar. Standard deviation is the S of x. Here's your 5-number summary. All right. So just a little refresher on what those things mean. All right, so Brett, he's 74 inches tall. And only 2 students in this class are taller than he is. Okay, so here's Brett. And here's the 2 people who beat him in height. Brett's percentile is computed as follows. 23 divided by 25 equals 0.92 or 92%. So Brett's height puts him at the 92nd percentile in the class's height distribution. Now let's look at Mary. Mary is 65 inches tall. Okay, what percentile is she in? Mary is 65 inches tall. So I'm going to do Mary with some blue marker. So 65, there's Mary. All right, and I want to find out what percentile she is in. Well, how many dots are there below Mary's height all the way up to her actual height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is, she's in the 10th position out of the 25 students who were surveyed. And what does that give you? If you take that and calculate it in your calculator or simplify it, you'll see it's 0.4. So that means she's in the 40th percentile, which means 40% of the other students are the same height as her or less as far as height. All right, Joe. Joe is 71 inches tall. Let's go see where Joe is on our dot plot. Joe is going to be in, let's see, green. I haven't done green yet. So here's Joe. Joe. All right, and we need to figure out the percentile rank of a score, or I mean a percentile rank for Joe compared to all the other kiddos that have had their heights measured. All right, so 71. Look at your dot plot. Let's count where he is in the list, ordered list. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Joe is number 20. Out of how many? 25. So 20 out of 25, which simplifies to 4/5, which is 0.8, which is about the 80th percentile. So Joe is taller or equal to the height of 80% of his peers. All right, I'm going to have to stop this recording and pick it up again. So I will have a second one ready for you because I'm going to run out of time. So see you in a minute.